everybody see this slide, KPI Consulting, Happy Learning Week?
Yes.
Good. Good. Ganguly, is it clear? All decks clear?
Right, right.
Fantastic. Okay. So, first of all, very good evening to all the participants, and a special thanks for KPI Consulting Services for having this learning culture of Happy Learning Week. Now, over the week, about 10 days, we have seen a lot of webinars. Experts have come and they have spoken to you about the cutting edge technologies in the industry. Somebody has spoken about machine learning, Dockerization, various testing tools. And then obviously, whenever there is so much of technology spoken about, AI and machine learning cannot be left any behind. So as a successful trail to the session which we are having, we have incorporated the artificial intelligence, and most importantly, it's not a session around artificial intelligence. This is a session around how artificial intelligence with one of our hands-on case will demonstrate how things are getting rapidly disrupted in the industries commonly which either we are working or most commonly with which we'll be start interacting with. So this is a kind of a curtain raiser of the things which are in line and which are coming our way, and which is going to radically change the way we interact with the environment around us. So welcome to everybody. Again, thanks again for KPI Consulting for hosting me, and for all the participants, thanks for taking the evening out. I know it's a pretty busy schedule at all of your ends, but you have still taken out time. That marks a very positive emancipation from your end, that you are interested for learning, you are interested to hone in skills which are going to thoroughly disrupt the way the industry is progressing and the way we are changing the world, most of the time for good. Okay, thank you very much. A little introduction of where I come from, what I do. So my name is Mrinal Chakraborty, as Ganguly thankfully has introduced me to you. Me and Ganguly have been speaking to each other, and we are thinking of how could we make this session much more interesting for you. So it is a kind of practically oriented session with a little bit of theory, because if I just run practical and if I demonstrate to you how a convolutional neural network works, you would be interested to know what goes behind the hood. So we have kept that in mind, and we are, tried to keep you a mix. But before I go in further, let me introduce myself to you. So my name is Mrinal. I'm not a full-time trainer. I'm a full-time equivalent data scientist and a cloud solution architect. My specialization is on the Microsoft Azure cloud, but I also can manage and create AI and machine learning enterprise-wide solutions for Alibaba Cloud, AWS, and GCP too. Since this session is more around Azure, and we want to help you with something very quick and easy, so we thought of putting the rope around Azure and trying to learn one of the most popular things around Vision API. More about myself. So I'm a Microsoft certified solution expert around AI and analytics. My favorite machine learning algorithms are XGBoost. I love image recognition and its image and video recognition and its application towards our new disruptive industry practices. I'm also certified for PMP, design thinking, and stuff like that, which helps me put across solutions to various client needs. I'll speak about that much later once we go a little higher in our discussion, but this is who I am. So how do we want to get this session done? So at every 15, 20 minutes, I will pause for a while. I will try to get questions and we will consolidate and we'll progress. So if at all you have questions in every 15, 20 minutes, I'll ask you for that. And we will incrementally grow, incrementally learn. And I don't want you to wait for half an hour before you ask me the question, because by that time we would have covered significant ground and then you might be not following it. Okay, so this is what we have. So apart from the session, I also want you to understand the AI platform of Microsoft, the Azure AI platform of Microsoft. I wanted to give you guys a quick understanding of where this platform works. And while in the session, we will progress much on this platform. We will have a demonstration around this platform. As you know, AI is nothing but a conglomeration of vision, speech, language, knowledge, and search, as you pretty much see in my screen. We'll pick one of these examples as AI components, as you see on my screen. You know, all of you have heard about what AI is, a little bit about what AI is competing to do. You have heard about human-machine interaction, stuff like that. What we'll do is, AI is nothing but a composition of the cognitive skills and the learning mechanism, the way the human brain works, mixing these two up to create products and services which take the redundant work out of any of our current workloads. There could be many definitions on many textbooks around this, but this is the business definition of what AI is. So there are three main phases of this. One, it is a composition of cognitive skills. When I say cognitive, it is vision, touch, language, speech, knowledge, wisdom. Okay. Nobody teaches a baby that when it takes birth, it has to go and to its mother, right? It is cognitive skills of a baby, right? So all this component comprises of AI, the cognitive skills. Second, so what are the components of that? Vision, speech, language, knowledge, and search. What we will do, let me complete the definition and then possibly I will come. Next is to use the way humans think. So we will try to replicate the way the brain thinks. We'll try to bring in some of the algorithms the brain uses to use these skills and to create business processes which can take out the mundane work off and makes us more creative. That's the business definition of application of AI in our parlance. And we'll try to do with this. So instead of picking up all this five this evening, I'll pick up vision. And I will show you how is that with vision, I can demonstrate an AI application. And then we will go and see how this is could be disruptive and how it could be of social revolutionizing factor in creating a disruptive offering, which I was a part of. Okay, so we will do this as one of our hands-on session as along we deal with our session. So let me get back to the deck which we are talking about. Good. So Is the scope clear to everybody? What are we going to do in the next 1 hour, 45 minutes? Anything that you think we should discuss in this session other than this? Clear? So is it clear to everybody what we are going to do for next 1 hour, 45 minutes?
Yeah.
Good. Okay. Nice. So let me see the chat. Yes, it is clear. Thank you, Ekon. Thank you, Eknath. Okay, good. So let's start. So why AI? So we have been hearing so much about artificial intelligence. We have been hearing it doing things. So the question is, why should we care about AI? Should we care about AI just because the market is hot? Now, these are two newspaper articles that the same papers that you and I both read. The Times of India says the overall cost of hiring people with cutting edge tools is increasing on a year-to-year basis. These guys are getting the people with cutting edge technology knowledge like AI, machine learning, cloud computing, robotics. You will find all of this in our Learning Week theme. These people are getting more and more pricier because they seem to be chased by practically everybody. Why are they getting chased? Because on my right hand side, on an article dated 18th of February, you will look at that most of AI is getting used pretty much in startups, even at the case of matchmaking. So we have a site called bunnyhal.com, which instead of you browsing through 15, 19, 20 profiles of your prospective bride or groom, whoever you are, it uses machine learning and AI to recommend you some of the prospects based upon your behavior, your likes, your dislikes, and your attributions. So this is AI coming down to the most important part of your life, or AI helping you for your better half of your life. So all through this, we have been seeing AI being used extensively to disrupt age-old practices, age-old conventions, and of course, we are seeing this at many paths where the disruptive nature of AI is completely changing the way we do business practices for a couple of years. But is AI magic? The answer to this is it seems like magic, but it is all about math. The math that goes behind it. We will take a fuller look of what goes behind it and how is that the math progresses at each and every step, layer by layer, layer by layer, and then it proliferates itself into a product and then into wrapped around a service, and then you will see how things go up. So that's AI. It's not magic. It's about using cognitive tool set, using and understanding the way our brain works, trying to put them together to get rid of some of the mundane daily tasks which we can get rid of and rather focus on creative, productive, and more purposeful tasks before us. Okay, so before I get started, any questions? on what AI is, any issue with understanding where we are trying to get to, and any concerns around what are we trying to get done. Good. Okay. So far clear. Let's move forward. Balamurugam, thank you. Okay, let's move forward. So, if I were to show you this picture, good. Thank you, Seti. Okay. Okay. So, if I were to show you this picture through your native intelligence, through your basic intelligence that you have been acquiring in seeing similar pictures like this, you would immediately jump up and say, you know what, it's a bird. To be more specific, it's an owl. To be more specific, it's a rare species of a white owl. Okay. Now, as a human, if I show you this, okay. Now, please don't jump out that it is a Pakistani plane which was hit by India and we are so proud of it. Yes, we hit them. We will keep hitting them every time they create miscreants for us. But when I show this to you, you will immediately come and say, you know what, I understand this image. It's an image of a fighter aircraft. It too seems to have two wings. It has a tail. It has a nose. It has a belly. It is inspired from a design of a bird. That's why it is so aerodynamic. So though it looks like a bird, it seems to have an eye, seems to have wings, it seems to have a bulged head and a belly. But as with your deeper cognitive skills, as a part of your fully trained human brain, you can differentiate the left from the right. You can say the right is a mechanical stuff. It's a composition of software, electronics, mechanics to the highest degree of human intelligence and sophistication. Whereas something on the left is a thing of beauty made by God. And it's natural completely. And it has a thinking brain by itself. So you can make the difference. But if I were to send these two things to the computer, maybe it can't. Because like you, it has not learned how to make a difference before this. It has no training to take. It has no guidance. It has not read any books. It has not seen these beautiful pictures anywhere else so that it can be trained. So the computer cannot, without training, cannot differentiate between the two. Now we will just start our journey as the Wright brothers did about 150 years back with their aircraft. All of you will remember that this is the first aircraft which took flight for 16 minutes, 40 seconds, and then we will take a flight like this this evening, where we look at what is this KPI Consulting, and have patience, please. Sorry, I didn't get this comment.
No, not to you. You can carry on.
Okay, clear. So this is like the journey which we are going to take. We are like on the cusp of learning AI. We are taking our first flights onto AI, and we are trying to get ourselves going. Okay, and this is the very basic level. Okay, you're not going to enjoy a supersonic flight here. You're going to get a level 100 of AI with an Azure, and we are going to right away start our journey from this part. Okay, good. Now, the emphasis of AI, as I was talking to you, is the premise that we are going to replicate the way the human brain thinks. And what is the composition of the human brain in that case? It's nothing but a set of 1 billion neurons working together. Okay. So in that case, what's a neuron? So a neuron is nothing but the most atomic unit of the human brain, which does a very simple function. It receives a signal, and according to some logic, it propagates the signal out. That is very similar to the circuit board in your circuit, right? It receives a signal and propagates the signal back. And if you connect all these neurons together, I mean, how does the human brain look? It is nothing but, it is not an single neuron working, right? It's a composition of millions of neurons getting together and working in tandem to do the signal passing. Okay. Now, for example, there could be the journey from the finger to the head could be a journey of lakhs of neurons, right? Like the nerve touches a particular neuron, and suppose you have dipped your finger in hot water, the finger passes a strength of signal to your brain. The brain classifies that signal is good enough to warn you to take your hands off from that hot water. A second or a couple of neurons more understands that drawing out of the hand is the signal to be passed, and that is what is done at the back end. So essentially, whatever action you take in your life, even attending the same class, is nothing but a signaling outcome of your brain's neurons. Okay? And when we put all these neurons in a network, what we have is a neural network. Now, we have all been wondering, well, how is this that we call the algorithms as convolutional neural networks? It's because that is exactly the way our brain works. And fortunately, we all have a 100% production unit right with us, which is much more brilliant than many computers connected together. That's how wonderful God is, and that's how wonderful the gift He has given to you. So this is a neural network. So it's a cohesion of all the neurons in our brain working in tandem to relay signal and to pass on a particular signal. So instead of going to a human's brain, I want to draw your attention to the pigeon's brain. So why a pigeon? Can the participants go on the mute, please? I'm talking about a pigeon, not a child in mouth. Okay, so Perkins cells is nothing but the composition of a pigeon's brain. It's a slide of the pigeon's brain, and it is a picture. Okay, so it's a picture of how the pigeon's brain looks like. Okay, now why are we interested with this? It is this which forms the basis of our neural network, which in turn forms the basis of whatever we are going to learn in artificial intelligence. Okay, this is, if I invert this back, I see this image. Now look at the stamp of this image. So this is a postcard by the Museum of Cajol in Spain, in Madrid. This postcard was studied in the year 1952. Okay, I'm getting that image to you. 1952 is when we started learning about neural network. when we started getting to know how the brain works. And it is only a couple of years from now, though the research has been going on, because of the intensive power of computers and the disposal of a cloud, is now where we are harnessing this power of understanding neural networks. So let's understand a little bit closer. So the axon is the fiber which connects the neural network. The soma is the central piece of the neuron where the processing is done. The dendritus is the place where the neural network gets connected to the other neural network. Okay. So if I technically draw these two pictures, so that's my axon, that's the soma, and that's the dendritus. Okay. So this is a combination. So if I'm just drawn this pigeon's brain into a simple architecture diagram, right? And the dendritus is one with which the other axons are getting connected. Let me show you the picture a little bit more. So eventually we are converting biology into mathematical concepts. So I've started with pigeon's brain. Then I've started with a neuron, which are typically zoology concepts. Then I'm moving into the mathematical part of how it is getting related to AI. So this is my dendritus. So if I receive a signal, which is very strong of a signal, so you would see the bars getting highlighted because my signal is pretty strong. So if my signal is pretty strong, I give out a very strong signal. It's like dipping your fingers in water. If the water is very warm, you will get a very strong signal, and you will immediately draw your fingers out from that part. Okay. The long thread-like part of the nerve cells, along with the impulses, are conducted from the cell's body to the cells. Yes, you are pretty much right. Yeah, you are right. Okay. So synapse. Synapse is where the connection between an axon and the neuron happens. So synapse is the place where the signal is getting passed from the neuron to an thing. So we will use all these concepts in helping you understand a neural network. Okay, and then we will show a demonstration of how this neural network is powering most of our disruptive technology. Okay, so you have to hang on with me to understand this concept, because if you don't understand this, you will not have a very good foundation of what is going to come in the next few minutes from there. Okay, so I've just converted this diagram into this. So this is where your two neurons interact. So the dendritus and the axon connect with each other, and the place where they connect is the synapse, where the signal transmission happens. So for example, if this is your nerve cell from the brain, and this is your nerve cell from the hand assembly, this is your nerve cell from the brain assembly. So this is your brain assembly working with your hand assembly, right? Just imagine them as two complex parts moving around. Okay. So I'm taking off the zoology part from my discussion now, and I'm retaining, and I'm slowly rather asking you to dip your feet into the lake of mathematics around artificial intelligence. Okay, I'm slowly welcoming you to dip your feet and start experiencing artificial intelligence from here on. Okay, good. So this is the place where the interaction happens. So if I pass on a signal which is of medium intensity, say of 0.6, 1 being the strongest, 0 being the weakest, and anything beyond 1 and 0 is medium, low to high intensity. So if I pass on a signal with 0.6 as an intensity, the neuron over here decides whether should I pass on the signal further or it is a weak impulse. I can just pass on the signal that the water is just warm. It will not harm you. You can keep your finger dipped there and enjoy the warmness of the water. Okay. So that could be that. So, but if I pass on a very strong signal, then this is an indication of a strong signal where the bar gets highlighted. And this is the indication of a very, very low signal, right? So like this, I can have many assemblies interacting with each other based upon the intensity of the signal, okay? And based upon the intensity of the signal here, I will pass on my output signal at the top, right? To my brain sub-assembly, maybe, okay? Everybody understanding what I'm trying to get done as of now? I've just moved on from zoology to math. I've put some probability number jumbo there, and I've trying to let you know what is the comparative difference between feeling of warm water to hot water to seriously hot water where you have to jump out and run, right? Okay, so let me take some chats. Let me see what is the understanding of all the people. I think it's going good. Good, very nice. Okay, let's move further. Okay, so now I've depicting my intensity of signal, no more with dirty yellow lines, but with the width of the dark line. So if the line is bolder, I have a high intensity signal passing through the neuron. If it is lighter, you get the number and it is pretty much out there, right? Now, let me go a little further from this. So if I connect this, I'll get a connected layer of neurons. Don't you feel so? So this is a neuron each. So there are about 5 neurons on the bottom layer, 3 neurons on the top. So if I connect this 3 into 5, now I have a fully connected layer. So I can pass on signal from any of this and it will go as per the intensity and as per the axon to dendritus connection among the 2 neurons, it will pass on a particular signal. So how does it help us? So whenever you do reading, you might not think about this, but whenever you read the word A's because the letters A, C, and E light up in your head, okay? And they tell you that, look, I am getting positive, very high signals for the letters A, C, and E. That's why you read a word called A's in your book or in your article that you're looking at, okay? And the other letters that like B, D, Z, Y, M, N, O, P, these get very, very feeble signals. So they don't get light up and you don't read anything of a word combination of that. So all that which lights up after reading ACE is this signal and you read the word A. Okay. So this is how your brain comprehends words after it sees symbols of letters. Good. Now, that's about letters, but how do you comprehend pictures? Which is where I'm trying to go. If you remember, I had told you that we have to deal with this use case, right? This use case where I will be taking up one of these to the vision, where I'll be taking computer vision to help you understand how does it read vision, right? So how do you read these 2 pixels being darkened and these 2 pixels on the bottom being brightened? So that is because the dark pictures have a very strong signal and the light pictures don't have any signal. So whenever I see a dark signal, I color them out. Whenever I see no signal, I don't color. So you can read this small information and recreate this image all by yourself. Okay. Now, the same is the reason with text. So if I have highlighted eye and highlighted ball, I read eyeball. If I have a multi-connected neural network, Now I can read sun and glasses to sunglasses. Now I can read eyeglasses, things like that. Now, what have we done with this? So what we have done is that whenever we read, we have got to understand how is the brain and the neural network in our head comprehending letters, comprehending pictures, comprehending words to let us understand the meaning behind those words. And it is so immaculate, you don't even realize this. This is happening in microseconds. Okay. Now tell me one computer which doesn't need any electricity, which doesn't need a supercomputing and which can do this. It's only you. Till today, we have not got an equivalent of how a human can think so creative, so fast, and with so many options. It's only us as a production system. Okay, good. So when we layer 2 or 3 of them to do multiple tasks, we have a connected layer with 2 layers out here. Okay. Similarly, now I can connect an input layer, the first layer, second layer, and the third layer. And whenever we have this connected layer, more than 12 such layers, what we have with us is a deep neural network. It is deep because it has more than 12 such layers to interpret something meaningful. And in most probability, your neural networks are n-layer neural networks. When I say your, what I'm talking about is how your brain works. This is an n-layer neural network. Somebody has raised a hand, so let me take what he wants. Okay. 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 So okay. So I don't know who is muted. Can somebody look into that? Yeah. Cool. So are there any questions to understand what is a deep neural network? Can everybody comprehend what is a deep neural network as of today? Is everybody clear with the concept of deep neural network? More than 12 layers. More than 12 layers. Yeah, it's called deep, but usually in all the AI projects, more than 3 is deep. And for practical AI engagement, deep is usually comprehended as more than. Okay, so all the production level deep neural networks are at least 12 layer network. Good. Okay. I was writing that in private, I guess. Okay. So okay, Ganguly has helped us. Okay, good. Okay. Any other questions? I'll move to stuff then. Okay, good. Okay. So what are we trying to do? What is the problem that we are trying to solve? Okay. So when I was working on a deep learning AI engagement, I was working for an 150-year-old company in Germany, which specializes in crop science. Now this company had to, for all the reasons, I cannot take the name of the company, but the company specializes in crop science, and the engagement on our hand was, can we develop a deep neural network so that we can understand the nature of disease of the crop by just clicking the leaf of the infected plant or leaf or stem or infected fruit, and we should be able to classify what kind of a if the plant is infected or the plant is not infected in level 1, or what kind of an infection the plant is suffering in a level 2 kind of an engagement. So what are we trying to do? So what I'm trying to do is, I want to, these are the images of my plants, of my crop. Okay. Now, if I were to take a picture of this over my app and send it to a deep neural network, it should tell me whether my crop is healthy or not. Okay. Or on a worst case scenario, if my crop is diseased or there is some kind of a problem with my crop. Okay. So here we are seeing a lot of problems. It has been, there is a weedicide, there is a infection, there is a soil related infection, and that is the reason why my crop is infected for some reason. Okay. Now, my whole business objective is, can I create and deploy an deep neural network model? In our case, a convolutional neural network model. Why convolution? That I will talk to you in a while from now. Can I create a deep neural network model in which a farmer, and make the life of a farmer very easy? All that the farmer has to do is get to his crop, take a picture like this from his or her cell phone, and she uploads this picture on my company's crop science app. And what I do is, I take this picture from the farmer's posting, I run it through my multi-layer deep learning neural network, and then at the end of the cycle, my multi-layer deep neural network classifies the image as whether it is a part of the healthy crop image or is it an infected crop image. Okay. Now, once this classification is done, as a stage 2, first stage, I just classified whether it is healthy or diseased. And then once I classify it, whether it is, if it is diseased, then I take it further and further classify it into a level 2, where I can clearly identify whether it is a soil-based disease, whether it is an infestation-based problem, whether it is a weedicide issue, whether it is caused because of rodents, or is it because climatic fluctuations and things like that. That's a multi-class classification of where the disease is. Now, why is it important that I understand this classification of disease? Can anybody help me with an answer? Why is it important that I understand which class of disease is my crop infected with? Yes, participants? So that we can ensure that to keep it neat to discard, okay? To get it treated right. Yes, Vikas? Balamurugan, to go for proper solution. Yes. So you all are hinting me to the same thing which my client wants me to do. You all are very intelligent. Thank you for your responses. Yes, precisely what all of you are telling me. So I need to understand this because as a company, I can now say there is a one-to-one mapping of the disease to the solution. So I can say if it's a weed problem, then use this weedicide. If it is a rodent problem, then use this chemical. If it is soil-based infection problem, here you go. This is chemical XYZ that you can buy from. And that's exactly what the 150-year-old German chemical crop science company did. We did a one-to-one mapping. Once we classified this through our neural network, what we did is we understood the nature of the crop's disease and we recommended that particular solution to the farmers. And apart from doing that, we also gave the farmer an Uber coupon so that he can drive up to that particular place, get that particular chemical and use it in his particular field. Okay. Now, one thing which is fundamentally different from a German field and an Indian field is that the Germans have field sizes, farm sizes, at least 20 to 30 times the average size of that of an Indian farm. Okay. So it is physically impossible to go at every corner and manage and have a look. So usually they send a drone. The drone captures these images like these and it sends out to the farmer and the farmer then can put it on an app and things like that. So it fundamentally changes the way the farmer gets advice from a crop science company. Isn't it? This has disrupted the 150-year-old model of how a farmer gets advice on how to disinfect his crop. Earlier, whenever the farmer used to have this kind of a problem, he had to go to a retailer, ask him the advice, and then whatever the retailer finds fit or whichever product he enjoys the largest margin of, he would push that product to the farmer. And our farmer used to get that, and if he is very lucky, he used to get results. And if he is not lucky, then the whole crop would get devastated for the season. And this is the first time we are seeing where AI is disrupting the complete farm economy, where I am giving a 150-year-old company for the first time is interacting with the farmer on a one-to-one basis without a middleman. Okay. And the farmer is getting benefited by such a technology which can precisely point him what he needs to put in his field to get rid of the problem. Is this very, did you understand this reason why we are looking at a deep learning algorithm? Why we should be investing so much to learn deep learning? And how is it that it profits us to look through the lens of a business problem? Did you understand this? Any concerns, any doubts that you have around this? Perfect, good. Very nice. Balamurugan, thank you. Shubhamakar, thank you very much. Very nice. So it's one thing to look at technology. It's one thing to look at Azure, AI, Google, all these things are one place, but it is very important as an architect to understand how are you going to relate this technology to the business problem on hand. And I would rather suggest whenever you learn technology, you have to first ask yourself, how am I going to relate this to the business problem or business opportunity on my hand? And I always want you to keep that prism of check, the lens of validity. I want all of you to wear that lens of validity with you all the time. Like you carry your mobile phones, you should carry this lens with you all the time, everywhere, whenever you're talking about deep learning technology. Okay, very good. Okay, so let's proceed. Are you interested to know more about deep learning now? Are you interested to understand how this thing works in practice? Are you interested to get a demonstration of how this thing actually works? Good. So now,
Yes.
for the next, yes. Anybody was on the voice? Okay. Good. So, well, Can you explain about convolution? Yes, I'm getting there. Okay. So I want to go to convolution neural network. I want to go to all the subjects, but most importantly, I want you to carry this lens with you. Okay. As a practitioner of AI, as a practitioner of machine learning, if you cannot speak the language of business to an application of AI or ML, you're going to be rendered as a technocrat. You're not going to be rendered as a problem solver. And there is a big difference between the two. We'll understand that much better. Okay. Okay. Let me dig now. Okay. Now let's get back to some of the concepts which we are going about. Okay. Good. So now we will learn all these things in a simple demonstration of image tagging problem. Now, all that I have to do is, if I can help a farmer just to click an image of his crop and get to understand whether the crop is healthy or diseased, and in phase 2, what kind of an disinfectant he has to use, that is where my AI is helping my farmers. That is why lakhs of my onion farmers can get benefited with a better price, better respect to their farming ability, and a better respect from customers like you and me for the hard work they put in sun-ridden fields. Okay, and when it comes to a refrigerator, it is all cool, it is all good. The tomatoes are so ripe, but for that ripened tomato, a lady has worked for 12 hours in a hot sun for maybe 2 or 3 months, and we want to use the technology to help her. And as technocrats, as people with technology, I want you to reach and understand their problem and create an AI for them. Good. So let's move forward. So what we are doing today is learning one of the simplest ways to do this image recognition problem. And we will do this with our very basic AI component, which is the COVNet, or the convolutional neural network. Okay. Somebody was very enthusiastic and to learn about COVNet. So here it is for you. Okay. We will go step by step to understand how do we help this farmer at the end. And then we will do a demonstration of how at the end we have helped this farmer to do things. Okay. Cool. Can I proceed from here? Anybody has any issues, any questions, any concerns? Anything which I need to explain you? Good. Okay. So let's proceed from here. Okay. Oh, I might have skipped that slide. Okay. So here is what we need. So if I have, let's take a toy example. So if I have 2 images, one is a cross and one is a nut. So if I take 2 images, a cross and a nut, and if I pass them through my convolutional neural network, now you already know what a neural network is, and I will explain you what a convolutional neural network is, but you understand what the NN part of the CNN is. So if I pass them through the convolutional neural network model, I should end up with these 2 images being correctly classified So if I pass a cross, my CNN should tell me that this image is actually a cross. Or if I pass a nut, this image should tell me that I have passed a ellipse or a zero or a nut. Okay. Now, why is this important? This is superly important with respect to the demonstration and to the respect to the thing which we are trying to do. So what we are going to do, we are going to pass some diseased crop images, and we are going to pass some of the healthy crop images. Okay. Now, if the crop image is healthy, I want it rather to classify it as healthy. And if it is diseased, I want it to be flagged as diseased. Okay. I hope you're understanding me where I'm going and what I'm trying to do and how I'm going to relate it to the demonstration which I'm going to make. Okay. In case you have anything, please chat. I will explain you a little more about what is the objective. But I assume that the objective is very clear among all of us, right? Okay, good. So let's move. No, X is not diseased. I'm just, again, it is just the two classes, okay? Here, if I pass X, suppose X is healthy or X is diseased, whatever it is, imagine this to be two classes of images. One class is healthy, one class is diseased. Or in this example, in a toy example, which I'm putting on the slide, I'm taking one class as X images, one class as not images. That's it. Two class problem which we are dealing with. Okay, cool. Okay. Yes, Mishraji, the uneducated farmer also can use it. I think the uneducated farmer is more worldly wise than most of the educated technocrats living in the cities. But to answer your question, they too can use it. All they have to do is take an image of their crop and send it over their mobile phone app. And the mobile phone app relays this image to the deployed neural network on the crop science company. The neural network processes this particular image on a cloud, essentially an Azure cloud or an AWS cloud or whatever cloud you want to use. It processes this image on a cloud, and then it comes back with a resolution whether it is diseased or not. So all that the farmer has to do is upload an image and wait for a minute or two to get a response whether the crop is diseased or not. And as a phase 2, he will get a recommendation of what chemical to spray for that crop. And yes, as you rightfully remark, some of our uneducated farmers are much better off, much better wise than some of us, including maybe me. Okay, so let's go deeper into this and understand this before it fizzles out. Okay, so let's go next. So now, the trickier case is, even if I translate this, even if I scale this image, rotate this image invertedly, or add more weight to this image, my CNN should be resilient enough to tell me whether it is the right classification has to be made. Okay. So for example, if the poor farmer uses a VGA camera and the image is not that good of a quality, still I should be able to give him the clarification whether the crop is diseased or not. Okay. So if by some means the image has been inverted for some reason, okay, but still if the image is being posted on the farmer's app, I should be able to tell whether the crop is infected or not, or still do the two-class classification. Everybody with me? Everybody understands this, what we are trying to get done? Perfect. Okay. Okay. So some understanding of the project. So the training of the model is done over at least 10 million images. Okay. What I'm going to do with you in the next 45 minutes is just give an understanding of how it is done. Okay. But the training in actual production cases, we did the training on 10 million images. Okay. And only then we got an accuracy of 95% probability that this image which you have uploaded is actually a diseased crop. Okay. You don't want to go to a farmer and say, you know, you have to spray weedicide on this particular crop when it is, you're only 74% sure whether the crop is infected with a weed or not. Okay. You never want to do that. So you train this with at least 1.5 million. We did it for 10 million images, and then we got to a product like that. Okay. So we'll go understand this. Okay. Cool. We are excited. So let's move. Okay. So let's go. Now, the problem is, can a computer tell whether these two images are similar? You and I ask this question, we both will say that, yeah, these two were similar images. But when I pass these two images through a computer, in most probability, the computer will read it this way. And it says, I do not find any matching between the two. And the computer comes back and says, these two are different images. Okay. Now, when you click an image through a camera, you know that the image could be distorted. The image could get some artificial weights. It might be disoriented and things like that, right? But the computers are trained to do literal matching between the images. Okay, they don't look at property matching between the two images. Now, so that is the reason why we cannot do a literal matching of an infected image to a family of images. Literal matching fails at that part. So what we do is use a concept of convolutional networks to match pieces of the images or properties of the image. Okay. Now this is very similar to face recognition. Okay. Now I'm drawing another parallel. Okay. Now you have to tell me if it gets too complicated for you, but I'm trying to mash in these concepts because tomorrow, if somebody tells you how face recognition is done, you can jump out of your seat and say it is not a literal match from what is your face and what is the database of 10,000 faces. Okay. This is exactly how face recognition is done. So whenever you put subject a face recognition problem, all you have to do is compare the nose, ears, eyes, lip, distance between the lip and the nose. These are all taken out as separate parameters, and these separate parameters are now matched with a database of such parameters lying in your object-oriented database. Now, once you match these two parameters, the images which are the closest distance between the two, it gives you the match. Okay. And that, after a lot of training, gives you an accuracy of around 90+%. Okay. So what you do in facial recognition is that you don't take a face and literally match it to 10,000 more faces in your office. Okay. What you do is you take out features of this particular face, like your ear, for simplicity reasons, and then you match these features with features of 10 million faces. And of all the distances which are nearest, which are similar to each other, then you spot a face which has similar distances like this, and then you say these two faces look similar to me. And that is how a computer does a matching. And the algorithm to do that is our convolutional neural network. Okay. Am I clear what I'm trying to get done? Any questions, any concerns of what fundamentally convolutional network is? Is that clear? I'm coming to that, Shubhankar. So I'm coming to that. We are, yes. Convolutional neural network, I'm coming to this. Is it relevant to only images? No, it can be used even for sound and scripts too. So I'm coming there. That is the last part of my presentation. I'm slowly coming to where all CNN can be used. I've not yet covered CNN. I'm just started CNN, or convolution neural network. So once eventually when we get there, I'll help you with that. Okay. Good. So let's go further into this. So what I've done is I have taken small patches of this image, and now I'm comparing these patches with these patches. So technically what I'm doing is, technically we say we have created some filters. So these aspects of the image are the filters of the image. I'm taking these filters and comparing these filters to the target image. And then I'm going to make a choice whether these are right. So this is the filter on the left side. If you look at this, this is the filter on the left side. This is the filter of the middle side, middle portion of the image. This is the filter of the middle portion of the image. And this is the filter on the left corner of the image. If you look at this, this is the image of the left corner of the image. Now what I do is I take this features or this filters, and then I start matching them. See, this is the upper left. Okay, good. So now I line up these features, multiply each image pixel by the corresponding feature pixel, add them up, divide by total number of pixels. Now, this is what the algorithm does. Now, even if you are not technically following all these steps, these are now going to be a little more difficult, right? So you have dipped your feet in the pond, in the lake, right? Now I'm slowly asking you to get inside the pool to enhance your experience. Okay. Now you're getting a little deeper and deeper into this. So we are talking completely math now. Okay. So you have to be with me. Even if you don't understand much of it, you can always come back, listen to the recording once more, and get a clearer function. Okay. Clearer picture of this. Okay. So what I'm doing is I'm taking this feature and then I'm multiplying this with my target image. Okay. See, very, very simple. Okay. Clear? So I'm just doing this. So I now place this over here. So I'm added up all of this. Since they are 9 pixels, I've divided them by 9. And all ones, so 9 by 9 is 1. So I've placed them 1 over here. Okay. Clear? We will run 2 or 3 of them more. So now I'm comparing this patch with the middlemost function, middlemost part of the image. I'm traversing this patch to the middlemost part of this image. I am calculating this, and this time I got a 0.55. So I've calculated all this. So I multiplied 1 with 1, minus 1 with minus 1. So I got a 1. Minus 1 into 1, I got a. Okay. So I've traversed this and I put the number of 55 over here. Okay. Like that, I am traversing this filter across all the cells, and I get a NumPy array. NumPy is the numerical Python way. Okay, that is an array of you can say a vector of numbers. Okay, and matrix of numbers. So my image has now been converted into a array. Clear, guys? Is it understandable? Just by multiplying this pixel with this complete image, this filter with this patch, I got this array. Now I explained to you how I got 1, how I got 0.77 and things like that. So if I move further, if I'm moving further, I have convoluted. So technically I'm using the word, please mark my word. I've convoluted this filter on this image and I got a array. Okay, like that. If you remember to start off with, I have three such filters with me. Okay, this is the first one. This is the second one. This was the third one. Okay, so since I convoluted with this, I got three sets of arrays. Okay. Now, what I do is that I call this as the convolution layer. Why convolution layer? Because I have taken out this filters, convoluted it over a picture and got an array of numbers. Okay. So I have actually done a convolution and this is my convolution layer. Okay. Anybody has any questions around this? Good. Okay. It's going to be a little tricky, guys. So I understand. So I'm doing the math very simple way. I'm explaining the math beyond what it goes. Okay. The next layer. So this is one layer. Okay. Now, usually in our deep neural networks, we have more than 3 layers, right? So I at least have to stack 3 layers. Only then it will make much sense to me, right? Sorry. Okay, let's move forward. So this is my convolution layer, right? Everybody is clear with this. Okay. Now next. Now I want to add one more layer, which I call as the pooling layer. Okay. Now pooling is used to shrink the size of the image. Now why should I shrink the size of the image? Is my question. Now for answering that, okay, let me first tell you why should we shrink the size of the image. Now, if you really look at your camera, all of you might have a camera which is 20 megapixel camera, right? Clear? So minimum cell phone has 20 megapixel. So can anybody tell me how many pixels are there in 20 megapixel camera? So if you take an image of that, if you take a photo from that camera, how many pixels are you going to end up with in your photo? Okay, 20,000 pixels. Okay, good. So that is a 20 megapixel camera, right? So just imagine if I want to do all this process on 20,000 pixels, it is going to be computationally so heavy, right? Are you guys getting me? So what do I need to do? I need to curtail my computation so that I don't break. My cloud resources are pay-as-you-go resources, right? The more compute I get to use, the more I end up paying. But I need to reduce the compute to an extent that I don't compromise on quality of the output. Okay. So to devise a methodology which captures the largest quality of the image, but in the same way, it reduces the size of the image because of 2 reasons. One, I don't want to break my computer because of highly intensive calculation. And 2, my cloud resources are expensive. So I don't want to do unnecessary computations when I can capture the same flavor, same intent, same quality in less number of calculations. So that's why I have to reduce my size of the image or to compress my image. Okay. Clear everybody? Why are we compressing? So one method of shrinking the image size is called the pooling. Now pooling has various methodologies by itself. You have minimum pooling, average pooling, maximum pooling and things like that. We'll look at one of the pooling exercises. Okay. This will be our second layer in the convolutional neural network. Okay. So what is the second layer? It's about pooling. So we pick up a window size, we stride the window size. That stride is how many steps do you take in the window size. Walk our window across the filtered image, and for each window, we take the maximum value. So let me demonstrate it so that you understand it clearly. So we take this 2 cross 2, we find the maximum of this 2 cross 2 matrix and we put it across here. Okay. So the maximum value is 1. So we are talking about max pooling. So maximum pooling. So we take out the maximum value and go. Now this is a 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So this is a 7 cross 7 matrix, which reduces to a 4 cross 4 matrix. Okay, we are compressing our image. At the same time, we are capturing the complete intent of it. Okay, so I look at this and I do a max pooling of this. So I move across every cell. I get to understand the maximum of this and start putting it over here. Okay, so I move across this, and what I did is I did max pooling, and I compressed this image, which is an output of the convolutional neural network, onto something called a max pooling output. So if you remember, we had 3 filters. So I did the max pooling for 3 times, and I get compressed matrix of 4 cross 4. You could take any size. I just happen to take 2. Okay, cool. I will get back on this also. Okay, so what we have done is max pooling. So same thing, I have done max pooling on all the 3 filters, and I have got my max pooling layer done. Okay, now this is my max pooling layer also getting done. Now again, I have one more problem. The problem is I sometimes need to deal with negative numbers. Okay, now negative numbers is a very complex calculation for the array, because it makes it very complicated. For understanding how it gets complicated, you have to know a little bit of vector algebra, but I want to steer clear with all that details for this session. So we apply something called ReLU, which basically is a function which says everything below 0 to 0 will be converted as 0, and anything beyond 0 will be retained as the same value. So that is our rectified linear units function. So if this is a positive number, I'm going to return it as positive. But if this is negative number, I'm going to turn it to 0. Okay. So if you look at the number line, this is exactly. So anything negative, the y is 0, and anything on the y which is positive retains the same value of y. Okay. So I'm going to do this ReLU, and I'm going to get rid of all the negative compute from this, and this I will do it over all the 3 patches, and now I have got my ReLU layer in place. Okay, rectified linear unit layer in place. So we have 3 layers, so that satisfies the criteria of having at least a deep neural network. So let me go about doing this. So now I have my 3-layer neural network. One is the convolutional layer, one is the other one being the ReLU, the other one being the pooling layer. Okay, clear guys? Up to this you are all clear? At least you understand fundamentally what's going on. Can you see my screen, everybody?
No, Mrinal, we cannot able to see the screen.
Okay. Okay, can you see my screen now?
Yes.
Okay. So this is essentially the components of stacking neural network in ourselves. So what I have done, if I go on doing this for 3 or 4 times, I end up having an vector. I end up having an array of very small size. Now this is computationally very easy to deal with. So after doing this learning, now this is very easy for me to deal with. So I will look at this. So then I get the fully connected layer. I ask every one of them to vote. Okay, let me take questions. I think there are many questions. Okay. We are recording the session, so you will be able to upload here. Okay. Need to leave the team. Can you share the link? Yes. Okay, nothing to go to. Okay, so what I do is then the fully connected layer gets to vote for if it thinks it is X or if it thinks it is 0. Okay, so whenever you have strong ones, you would actually vote it to X. And whenever you would have the otherwise, it will get voted to a not. Okay, so by this means I get to vote what initially I had passed. So I get to vote that my average of my vote is 92% towards X and 0.15 towards the not. So if I do this stacking, so I had done this is one stacking. If I do this stacking 3 times, I get to understand this a little more better, and then I can have a multi-layer fully connected neural network, okay, which predicts the probability of it being X as 0.92 and 0 being 0.51. Okay, so if I pass this image, in most probability it will pick up that it is as X as 0.92. Okay, so let's go and look at a demonstration of this and how this works in practical. Okay, can people still see my screen? You're all with me? Are you all with me? Good. So let's see this. So now you understand the concept of how it works. So let's create a new project. And so I'm using the custom AI projects. This is a Microsoft Azure component. You can read more about this over here. So I have deployed this architecture over here. So solution architecture for image classification with convolutional neural networks. This is exactly what I was dealing with you, discussing with you. So let me put it on the chat window so that everybody can have a look at this. So chat, everyone. Okay. So whatever I've done, if I want to technically put it onto an Azure stack, I would actually go ahead and do this. Okay. And then what I'm actually trying to do is use the computer vision. I told you these all are part of the vision, right? Then we have a speech, we have language, knowledge search. All I'm dealing with today is vision. And probably in our next discussions, we'll pick up speech, language, and multiple language, online translation, and things like that. What I've picked up this for this evening is computer vision. You can read more about this over here and try this out exactly the way I'm going to do it. So let's create a project for ourselves and let's help our humble farmer to classify things. So let's create the new project. So I will say the crop project classification is the new project. Classification of an healthy or a crop disease. Now it doesn't have multiple tags, it has a single tag. It's a classification project and it's just for a general domain. Now you can use this domain for everything. So you pick up food and you take an image of the food and you train your deep learning algorithm with millions of images of food. Now these images could be either of stale food, infected food, good quality food. You train your algorithm with all these images, and you can use this particular example for even detecting whether your food is stale or not. All that you have to do is take an image of that food on the app. The image goes onto a deployed machine, convolutional neural network model. It classifies it whether it is stale or not, and it comes back. Let's do this. Let's create this project. Okay. Okay. So this can be pretty much moved to Azure. You can pretty much do this. So this is again a custom vision API from Microsoft Azure. So let's add some images. So let me go in here, healthy, train. So what I'm doing is I'm training the convolutional neural network to identify healthy images. So whenever what I'm telling the convolutional neural network is, now this is how you should identify an healthy image. So I'm uploading around 27 healthy images of crop, and I am telling that this is the way you need to classify it. If you find something of a pattern like this, this is the way you classify it as healthy. Okay, done. Good. Okay. Now, so let me add a few more images, and this time we will add images of deceased. So okay, and if you see these images, give me a second, it will upload. So if you see these images, you will find yourself, and these are not very hard to find. You can just go to Google. See? Similar images which I am using. Okay, I'm not created this example just to showcase how bright I am, right? You can pretty much download any of these images and start using it for yourself. Okay. Okay. So let me get here. Where was I? Okay. So now what I'm doing now is I'm training the deep vision API. I am training the neural network to identify the healthy images and the diseased images. Like I told you, all the science behind identifying the X's and the zeros or the nuts, right? It has to go through various layers. So what I have done, what is being done in this particular AI, in this tool, is that they have already done that components of the ReLUs, the convolutional neural networks, the normalization, the connected layers, all this part of the things have already been done. What I'm doing is putting this image and training the model. Okay. So now let me train the model. Okay. So guys, so what am I training for? I'm training the convolutional neural network to understand what is a healthy image and what is a diseased image. Okay. Now, it has done the training and it says the model has this kind of a precision and this kind of a recall. Now, what is precision and recall? These are qualitative terms of how good the model is. Okay. Now, if you really want to understand precision and recall, just go to understand the confusion matrix wiki. So this is our confusion matrix wiki, and here you will understand what do I mean by accuracy of the model, prevalence of the model, precision, and recall. This is exactly what is being used here. Precision and recall. Okay. All that you have to do is understand this matrix. But I will not explain this matrix in detail. You can always do this and understand it. And most of you might already know it. So what I'm trying to get to know is my model has this kind of a quality mechanism, this kind of a quality assessment of the model which I work. But then the proof of the pudding is in its eating, right? So this is okay. I have done this. So how do I test it? How do I know? So tomorrow I have built the model, but tomorrow if our farmer friend has to use this model to test whether his crop is infected or not, let's guide him to do that. Let's earmark on the journey to do that. So what I do a quick test. I say, okay, let me look at an image of an healthy part. Let's look at this test. Okay, what I'm testing is this image I've never fed for training. Okay, so my folders for training and tests are very different. See, I've used only training for train. So this is a very new image. Okay, so I've just say, and now it's as good as a farmer clicking this picture and uploading it over here. And now he's waiting to see what is the probability of it being healthy and what is the probability of it being diseased. Okay. So our prediction is that the image which the farmer has uploaded is 100% healthy. So you need not do anything with this particular crop. Okay. Now let's take the other side where we pass on an image of an infected plant. So I'm going to test it with an infection. So let's test this with an infection, this one. And there you go. So it says the model is saying with 100% accuracy, with the probability of 100%, I can tell you that this plant is infected or this crop is infected. So let's test with one more. Let's pick up this one. It says 100%. Let's pick up this one and say what it says. It's still 100%. So the model is so good that it can say for sure with 100% probability that this particular crop is infected because of the pattern it sees on its leaves. And that is because we have trained the model with such good precision that it can now tell me whether any farmer uploaded picture could either be a diseased crop or an infected crop. Now look at the ramifications of this. You can use the same model to classify banknotes, to classify fake debit or credit cards just by the image of that. You can classify stale food, okay, or you can classify counterfeit Gucci bags, okay. So you can do a lot of things with this. You can also identify whether the powder, white powder that you are looking at, it is actually a drug or talcum powder based upon the training which you have done, okay. So lot of implications of this kind of a vision, and I've just started with vision after deploying this model. We still have lot many things to do. I'm just with image. I can now look at speech, I can look at language, I can look at knowledge, and it's pretty limitless of what all I can do with this kind of deep learning. And the good thing now is that you clearly understand what goes behind this and how it is getting done for you to understand the right way of how something is getting classified, okay. And this is not just with images. I can take sound, okay, and I can use the sound wave and I can break the sound wave into a pattern of numbers, a pattern of an array of numbers, and I can pass it through the same technology of convolutional neural network, identification of text. Everything can go through this framework and classify whether it is this kind of a sound or it is anything else. And it is just not limited to 2 or 3 classes. It can be extended to 5, 6, 7 classes, and I can exactly figure out that one. So I will take a pause now. I will look at questions, and if you can help me with questions, I will be more than happy to. We have covered a significant ground at that up to this, and I would rather take some questions and help you with clarification. Okay, how can you compare knowledge? So knowledge is, see, for example, if you have the knowledge that excuse me. So if you have the knowledge that your attrition rate goes up on every March, sometimes we have an understanding of why people wait till the last increment and then they think of moving out. Now, this data is being captured that people exit mostly after the 31st of March. But then it is also the wisdom of the HR lead, which says at the end of March, please expect an attrition of 20%. So what you're doing is you're adding a weight to the model, saying that all the other months you might have a attrition rate of a single digit, but then at the end of March, you're going to have an attrition rate shooting up to 20%. So that is given by the leader, and that knowledge is being transferred to the model, so that every time a model looks at an attrition of March, it adds more weight to that particular data point. And that is how you pass on knowledge to that. This is one simplistic way of how to put it as passing on knowledge to them. Yeah. So what is the difference between AI and ML? A very good question. So machine learning concerns itself mostly with fitment of statistical models on data, whereas AI, to be more precise, relies upon data to tell its own story. For example, I didn't fit any statistical model on the images of those plant images, right? I rather took the help of the convolutional neural network algorithm for itself to find out features which it could seek to attribute to an healthy plant or to a diseased plant. So here in AI, we are basically looking at the model learning of data, whereas in machine learning, we are talking of fitment of a statistical model on a particular data set. Thank you. Any more questions before I move forward? So, good. So, so now we fully understand how is that our model can be used for doing various such work. This is just a two-step classification. Now you can extend this model by training it with you can upload another set of images. Now you can upload another set of images here and say these are these are infected by soil infection. Okay. Now, and then you can go ahead and say this is the classification of weedicide. This is a classification of soil infection. Now, this can easily move on to an Azure free trial. Okay, this is your app name, this is your project ID, and this is your keys. And this can move to Azure in just one click. This is out of AI custom Vision API, which Microsoft proliferates around Vision API. But see, simple 2 clicks and it moves to Azure for consumption, right? It has been so easily done to help people like you and me who don't want to go into the nitty-gritties of understanding how do I configure a deep neural network, how do I get to the bearings of deep neural network. All you have to do is use a pattern of a network which has already been given to us. All you have to do is use this pattern for your usage. Forget about what goes underlying this. As a data scientist, you have now, as a data analyst, you now have an understanding of what is under the hood. All you have done is uploaded images at the one end and you've got a resultant at the other end with an probability score. Okay. And it is only you, after attending the seminar, who understands what goes at the back end. So it's becoming, so Microsoft in a way, it is in line with the societal benefit of proliferation of AI and ML, so that it starts helping developers and architects use these components, use these components which have been pre-written, pre-made, use them as prefabricated components on your solution. So all that you have to do is create an API hook to go to this service, fetch this service, and get it back onto your app. Okay, it makes it very easy for deployment, development, deployment, and usage. Okay, that is what Microsoft Azure enables us to do AI with such simplicity, without letting us completely write code for all those neural networks. There are so many cloud providers. Is there any specific advantage using Azure over others? So practically every cloud provider has its own USP. So some cloud providers are very strong at image, vision. So if you look at the Google Cloud Platform, they are very good at image, vision, because they are incorporating these features into their phones. So today, if you put a Google Lens on an Spanish text, you will automatically get that converted back into English, right? So every cloud provider has its own set of marquee products and its own set of great features. So as an architect, as a data scientist, you need to decipher between which cloud to use for which kind of functionality and for which kind of use case. Okay, I find Azure this very helpful to explain my architects around how to use this, how to use neural. So in just about a 2-hour session, you could understand how a deep neural network works, right from a postcard of 1952 to an image of 2019, right? So this tool, this Azure Vision API helps me to great extent to proliferate this knowledge of convolutional neural networks and AI. Like that, you can go and look at the Google Cloud Platform or the Amazon Web Services to find similar offerings. Yes, the whole point of having a convolutional neural network is that once you do the training, the more number of instances of images you throw at that, the model starts learning of that. So we have higher degree of neural networks. There is a long short memory model which tries to learn more of what it has seen lately. So there are various sophisticated neural network models. I've just discussed the one very basic one, which is the convolutional neural network. There are again many very sophisticated ones. The normal ones actually start at number 45 layers. Okay, the production quality neural network would actually kick in from 45 layers to 47 layers to 57 layers, and things like that. So again, a lot of things to look at: the hyperparameters, how many layers you want to do, what kind of an accuracy are you good to run with. All these things contribute to understanding of how many layers of neural network you need to construct, what kind of output quality you like to look at, things like that. Okay, so it all goes into those aspects of it. Okay. Good. Any more questions that we have this evening? No, I'm saying 45 layers is what we consider as a basic minimum production quality neural network deployment. You can go as well to 128, which is the competition winners are 128, 130, 150s, 170s layers of neural network. So when I say layer, what I usually mean is this layer, right? So this is hardly about how many, 3, 6, 9, 10 or 11. I'm talking about production quality layer being 45 or the competition winner being 128, 130 plus. That's what I'm looking at. Okay, Ganguly, you there?
Yes, very much.
Good. Ganguly, just in case if you want to summarize on some of the takeaways from this particular session, and what are the next steps you would like your participants to follow, and what do you think as an assessment of the session is? If you can help us with that, we'll be more than privileged.
Definitely, definitely. So there are a lot of sessions on the advanced topics we would be hosting on. That is the first thing, and also we will be launching few micro learning workshops with the professionals like Mrinal. I mean, he is having so many years of experience with the hands-on experience with this particular technology, and we wanted to host many more series of webinars. So please stay. Definitely update you. Okay, somebody has an awesome session. Mrinal, you rock. Yes.
Thank you very much, guys.
Yeah.